Welcome to Brain Vision.
So we're given a block of mass 200 grams, which is 0.2 kilograms. And for the first part, we want to figure out the kinetic energy, which is going to be pretty easy because they give us the velocity, which is 1.5 meters per second. And this is going to be the final velocity because it's at the bottom of the bowl. So the kinetic energy, it's also the final kinetic energy, is 1/2 times mv final squared, which is 1/2 times 0.2 times 1.5 squared, and that's 0.225 joules. Now, the next part, we want to find how much mechanical energy is transformed into internal energy, and that's basically code for work due to external forces. So I can say that the initial energy is going to be the final energy, and this is total mechanical energy, plus work, and this is really work external. So this work external is going to be the initial energy minus the final energy. So we can split this into initial kinetic energy and initial potential energy and final kinetic and final potential. Now the initial kinetic energy is 0. We're starting from rest. The initial potential energy is mgh, and h is just the radius of the bowl. The final kinetic energy we figured out in the last part, and the final potential energy is 0 because we're basically at height 0. So get rid of the zeros, and we're left with 0.2 kilograms times 9.8, and the radius of the bowl is 30 centimeters, which is 0.3 meters. And then subtract the final kinetic energy, which is 0.225, and you get 0.363 joules. Now the last two parts, there's no way that you can really easily figure out the coefficient of friction just from this information because, well, as the block slides down the bowl, right, its weight is changing directions in which it's pressing onto the bowl. So basically you have just a little bit of weight here and then even more here. So the friction is actually increasing as you go down the bowl because there's more weight that's pointed perpendicular to the surface of the bowl. So as you get down here, there's a lot of weight, but up here there's very little. So it's basically, since the friction depends on the normal force of the bowl, it's always going to be changing because the angle is changing. So there's no real easy way to just plug into the equation and solve for the coefficient of friction.